All right, let's dive right into this explainer. Today, we're unpacking a massive paradigm shift, the SolveForce Unified Intelligence Synchronization Fabric. We all know how incredibly fragile traditional networks can be, right? I mean, we've all seen the chaos when a single severed subsea cable or one botched software update takes out half the global internet. It's an absolute nightmare. But today, we're looking at a complete architectural overhaul. This ecosystem literally transforms raw bandwidth into planetary-scale governed intelligence. We're talking about moving way beyond just connecting devices to actually creating a synchronized, self-aware digital nervous system for the Earth. It's a game changer.
To really grasp how this architecture pulls this off, we're going to take a quick bottom-up tour. We'll start with the zero-point baseline, move into infrastructure as a language, check out multi-agent synthetic intelligence, unpack the synchronization fabric itself, and wrap up with governed planetary intelligence. So, let's start at the literal ground floor. Section 1, the zero-point baseline and eradicating entropy. Because here's the thing, you simply cannot build a unified intelligence on top of a chaotic foundation. Before a single drop of intelligence is applied, the physical hardware has to undergo a ruthless verification process. According to the blueprint, this means deploying server nodes and network switches that pass exacting sanitization protocols. Think of it like a flawless global factory reset before any software is even allowed to boot up. Every single piece of hardware has to have a unique, immutable identity, usually anchored in a hardware-based root of trust. Why? To establish a state of maximum order and minimum entropy. If this foundation isn't perfectly incorruptible from millisecond zero, everything you build on top of it is at risk of latent corruption or architectural drift down the line. And this brilliantly illustrates the shift we're talking about. We're moving away from reactive, fragmented hardware into a unified, programmable entity that acts almost like a living biological organism. Legacy IT is deeply plagued by systemic entropy. It's basically a Frankenstein's monster of regional monopolies, proprietary standards, and hardware that stubbornly refuses to talk to each other. It creates massive friction. SolveForce completely breaks this bottleneck by introducing a software-defined layer that treats the entire planet as a single self-healing switch. Because it takes a language-first approach, it can actually detect outages and route around catastrophic physical failures in mere milliseconds. No more waiting around for manual fixes. Which brings us perfectly to Section 2, Infrastructure as a Language, focusing on telemetry as language. Now, what's really fascinating here is how SolveForce treats telemetry not just as raw, dumb data, but as a living, breathing language. Let's look at how this builds seamlessly from physical reality all the way up to operational intelligence. Every transition here is intentionally engineered. It starts at Step 1, matter. That's the physical transmission through subsea glass and copper. That matter generates a signal. Then, in Step 3, that signal is modulated into a language of packets and syntax. Step 4 interprets that language into precise meaning. And finally, Step 5, that meaning authorizes a governed action. It is a flawless, step-by-step transition from physical voltage straight to a high-level network command. The source material categorizes this beautifully into what it calls the axiomic triad. We have the physical layer, the semantic layer, which they call mnemonics, and the logical governed layer. To make this super concrete, think of it like a traffic light. The physical glass and the electricity of the bulb, that's the matter. The red light it emits is the language. But the traffic law telling you that red absolutely means you must stop, that's the governance. This semantic layer ensures that every single signal on the global network is translated into a precise meaning before any automated action is ever authorized. The system doesn't just blindly push packets around. It literally asks, what is being expressed here, what does it mean, and what action is legally and operationally permitted. But how do we ensure these diverse systems actually agree on what this massive influx of telemetric language means? Let's dive into Section 3, Multi-Agent Synthetic Intelligence, and Achieving Consensus. Instead of trying to solve the entire problem with one massive, unmanageable brain, SolveForce deploys a sophisticated 10-agent intelligence system. Each AI has a distinct interpretive role. While there are 10 agents in total, let's focus on the core sequence that drives interpretation. Imagine a rapid-fire scenario, like a sudden network breach. Boom. The ingestion agent instantly pulls in the raw security alert. The linguistic agent decodes the syntax of that alert. Next, the domain agent, say one specializing in cybersecurity, flags it specifically as a DDoS attack.
Then the corporation agent cross-references this against past global attack signatures. And finally, the governance agent decides if blocking the offending IP address is legally and operationally allowed by the current policy. They basically act as a specialized, ultra-fast tribunal. And here is an absolutely vital distinction in modern AI. Multiple agents agreeing might just mean they share the same faulty training data, the same hidden bias, or the same missing context. That just creates a dangerous echo chamber. I mean, we've all seen AI systems confidently hallucinate completely false information, right? This is why, within the SolveForce architecture, corroboration always overrides simple consensus. Truth isn't established just because a few AI models spit out the exact same string of text. It's established through independent verification, calibrated confidence, and observable historical evidence. So once the conflict and calibration agents finish up their rigorous work, we reach the absolute last mile of the architecture, the operational agent. This agent has the massive responsibility of translating all this unified, verified knowledge directly into safe, bounded network configuration changes, automated runbooks, and security controls. This is the crucial moment where the synthetic intelligence actually meets the physical world to enact real, tangible change on the hardware. Which brings us to the absolute core of our explainer today. Section 4, the synchronization fabric, the cross-cutting layer. Now, to be clear, the synchronization fabric isn't a separate software product or some box you buy and plug into a server rack. Not at all. Rather, it's the common coordination law running horizontally through every technical tier, from the physical cables buried underground all the way up to the highest level operational policies. And it runs vertically through every state transition, too. It acts as the ultimate multidimensional matrix, ensuring that all the various agents and layers we just discussed are constantly operating on the exact same wavelength. Just think about the sheer scale of what this achieves for a second. It ensures that a sudden traffic spike in a Tokyo data center, a brand new security policy instantly deployed from an office in London, and a hardware sensor reacting in a remote edge gateway are all perfectly aligned in time, meaning, and state across the globe. By seamlessly unifying identity, time, topology, and semantics, the synchronization fabric makes absolutely sure that every single part of a planetary network can observe, interpret, and coordinate with every other part flawlessly. No translation errors, no lag, just perfect synchronization. Okay, so let's look at how this fabric enables the system to continuously adapt over time. Section 5, Governed Planetary Intelligence and Continuous Learning. This relies on what SolveForce calls a bidirectional coherence loop. Imagine the system trying to predict a major network outage before it happens. Step 1 is feed forward. It anticipates the massive strain and prepares the network. Step 2 is feedback. It measures what actually occurred during the event. Step 3 is reverse trace. It reconstructs the data to figure out exactly why its initial prediction was off by, say, 2%. And step 4 is recursive learning. It ensures the system is permanently smarter for the next global event. It guarantees that every single verified backward result actively improves the next forward prediction. And here's a really critical piece. Because the central knowledge graph, known as the codex, remembers absolutely everything, unification happens without erasing minority interpretations or historical contexts. If a system silences dissenting data or minority interpretations just to project an aura of confidence, it creates massive, dangerous blind spots. It essentially trades actual trustworthiness for the mere appearance of it. By preserving these differing interpretations, the system completely avoids oversimplification. Plus, it means it can always roll back and trace the exact provenance of any decision it makes. Ultimately, this whole architecture isn't just about faster downloads or lower latency for your business. It is about engineering an autonomous infrastructure that acts as a secure, self-healing nervous system for the Earth. The network processes the language of telemetry, the codex preserves the institutional memory and evidence, and the governed intelligence ensures that every action is lawful and exact. The network thinks, the codex remembers, intelligence governs. When you finally remove the friction of fragmented systems, outdated hardware, and isolated intelligence, the potential for human innovation becomes entirely exponential. Thank you so much for joining this explainer today. I want to leave you with this final thought. What happens to the limits of human achievement when our planetary infrastructure finally speaks with one coherent, self-improving voice?